we're going to do, we're going to continue on with our Chapter 4, Section 1, dealing with polynomial equations. By the way, this number here, and this number here, what do they refer to in the equation? What are we saying those numbers are? Those numbers are what's considered to be the roots, or the solutions, or the zeros, or the x-intercepts. So, remember we talked about yesterday that if we had a graph, let's try this here. If I were to draw a graph and I plotted those roots on the graph, we'd have a solution at a positive 3. We'd have a solution right here at a negative half. And then you'd have a solution right here at a positive 1. All right? And if we're dealing with this would be, what type of function if we have 3 roots? What do we call that function? Cubic. This would be a cubic function. So this is going to be y equals some number times x to the power of 3, and then there's a whole bunch of other stuff that we're not sure. So what would it look like? It would probably come up here from the bottom. It would go through this point, and then eventually rise through that point. So when we finally, at the end of this problem, when we find it, we're going to plug it in and we're going to see what the graph looks like. And it'll look something similar to this. Okay? I'm not sure how high it's going to get, how low it's going to get, but it will definitely go through what? A negative half, a positive 1, and a positive 3. Now, those are called our roots, also known as our what? Also known as our zeros. So what we're going to do is we're going to set our polynomial function equal to a 0. So how did we set this up yesterday? We used like 3 sets of parentheses, and we set it equal to 0. So what was one of the things I put in here to represent, if the root's 3, what am I going to write here?
Negative 3.
Yeah, so x minus 3. If that's a negative half, then this is going to be x plus a half. And if this is 1, then I'm going to write x minus 1. So that's what we did to start out, but then I didn't automatically jump to multiplying everything by a half. What I did was I'm like, you know what, let's take this guy and this guy, and we'll multiply those together. All right, so we're going to say x minus 3 times x minus 1, and then eventually we'll multiply it by the x plus a half. It's time for break?
No, it's not.
We still have like 30 seconds, Adam, before break. Well, you always listen to Noah? Golly. All right, everybody, the very first thing we're going to do, hope you enjoyed your break. Now we're back to working. We are going to take this right here, these binomials, and we're going to multiply them together. Now, I talked about a shortcut yesterday. All right? In the shortcut, what we did is we took the negative 3 and the negative 1, and I know I'm going to be dealing with an x squared. If you multiply x times x, you know you're going to have an x squared. Well, what did I do with the negative 3 and the negative 1 as far as the short? I added them together and I got a negative 4. So we put negative 4x. Then what did I do as well? Multiplied them together and I got a positive 3. Now that's the shortcut. If the number in front of this x is a 1, and the number in front of this x is also a 1, yes, Alyssa? Finish? Okay. Then, and only then, if you wanted to get the middle coefficient, by the way, we're doing it in the form of ax squared plus bx plus c. The middle will always be the sum of those two numbers. And the last number, the c value, will always be the product of those two numbers. All right? That's if and only if you have a 1x and a 1x. Now, if that does not make sense to you, YouTube viewers, then we can just do the FOIL method, where we do x times x and get x squared. Boring. And then x times negative 1 and get a negative x. Boring. And then, what do we have to do? Thank you for being patient, Alyssa. Negative 3 times x and you get a negative 3x. And then negative 3 times a negative 1 and you get a positive 3. But when you add everything together, you get the exact same thing as we just did right there, all right? So if you use the FOIL method, first, outside, inside, last, we're not going to talk about that. You should already know how to do that. That you could use the FOIL method for this. So this is our product right here. So what I want you to do in your journal, take that product, which is x squared minus 4x plus 3, and we're going to take that bad mamma jamma and multiply it by what? X plus 1 half. So we're going to do that next. By the way, go ahead and ask your question, or you want to pause it if you're asking a question. You want me to pause and maybe ask, or you want to? I did check my email, and I did not see anything about pizza day. So, for those of you who are listening, we are not going to have pizza day. And if you're listening to this, you're not having pizza day either, unless you're ordering pizza and eating it right now, then you are having pizza day. And we are all jealous right now, except for Leslie. She has string cheese. She's happy. Yes, okay. All right, everybody. Now, this one, there is not a shortcut, Caitlin. I'm just letting you know, there's not a shortcut for this guy, all right? However, what I want you to do is we're going to take this x value right here. Do you think you can handle doing this? All right, good. Take this x value and multiply it to every single term in this trinomial that I'm putting arrows to. Right now, what I want you to do right now is do that. Take this x value and multiply it to every single term, and let's figure out the products. I'll give you a few seconds to do that. All right, what's the product of our first terms? X cubed. I like it. What's the next one? X times this? Negative 4x squared. And finally, x times 3? 3x. Perfect. Now, once you have that done, then I'm going to slide over just a little bit to the right here. All right? And I'm going to take this half, and I'm going to multiply every single term by a half. All right, Noah, you want to do this?
Yes.
All right, start it out.
1/2 x squared.
Now, notice, when I say 1/2 x squared, where do I line it up underneath the other x squared? That's important. That's part of the organization process. Good. Next.
Negative 2x squared.
All right.
No, 2x minus 2x.
So we have half of a negative 4x, which is a minus 2x. Good.
And plus a 1.5.
All right. Plus a 1.5, but you know what? I'm going to be improper. And just put it as 3x. That's okay. 1.5 and 3 halves is the exact same thing. It's okay. I speak both fraction and decimal. It's all right. All right, now we need to add these together. So we just bring this down. How many? You got it, Alyssa? Go ahead. X cubed. I like it. I have a half, and I have negative 4. What's a half plus a negative 4? Negative 3.5. Well, watch this. Ready? I'm going to put negative 7 over 2 x squared. Because, by the way, 7 over 2 is equal to what? 3.5. All right? Then what do we have here? You got 3x minus 2x. That's right. If you had 3 x's and you got rid of 2 x's, then you'd only have 1 x in your life.
Oh,
That'd be funny if you watched the ID channel.
Everything harder.
I do watch that.
You do watch that. It's kind of, it's kind of interesting. I think we should sometimes watch the ID channel in high school so that teenagers realize how poor decisions, how they affect their lives.
Let's do this part.
No, we're doing math.
Great idea.
All right, now, and then we have plus 3 over 2. Now, by the way, everybody, listen. By the way, this right here is your polynomial function if you set it equal to 0, okay? So this right here is one version of it. X cubed minus 7 halves x squared plus x plus 3 over 2 equals 0. Now, there's other versions of this, all right? So, for example, what I'd like you to do in your journal, if you took everything, let's say you took everything and multiplied everything by a 2, another version that would still work. Well, if I wanted to get rid of the numbers in the denominator, you don't have to. No, I'm just doing this in your journal so you guys can see that you might have other options for the exact same equation. If I multiplied everything by 2, I'd have 2x cubed minus 7x squared plus 2x plus 3 equals 0. So what I want you to do in your journal is
That
have,
big two cancels everything out, right? Like the denominator.
yeah, this denominator, that would cancel out. So that's just another version. But what we're going to do in our graphing calculator right now is we're going to type in one in blue, and we'll type the other one in green so we can see the difference in the graphs, but they will still have the same zeros. Okay? So turn your graphing calculators on, and let's take a look at these graphs. All right, what's the blue equation equal to, Alyssa?
X cubed
X to the third power, right arrow. What else?
minus 7 over 2x squared.
Minus, I'm going to put alpha y equals enter. I'm going to type in a 7 over a 2, right arrow, x squared. What's next?
Plus x
Plus x, then
plus 3 over 2.
plus 3 over 2. Plus alpha y equals enter. This is just also a good way just to review how to use the graphing calculator, right? Okay? Now, what we're going to do right now is I want you to hit the graph button. Okay? And I want you to hit zoom forward. Let's take a look at it. A little bit easier to see. Now, right here, let's take a look at this real quick. We have a root right here, and where is that root located?
Oh,
Which one do you think that is?
negative.
Negative half. Oh, we have one right here. Where's that root located? At 1. And right here we have it at a 3. So this graph matches the roots that we started out with 11 minutes ago. All right? All right, so we go back to y equals. Let's go down here. I'm going to change the color over here. Since I wrote in green, I'm going to change the color to green. Is that okay? Okay. All right, so what's the equation?
2x cubed.
2x raised to the power, not plus, that'd be better. 3. All right, good.
Minus 7x
Minus 7x squared
Plus 2x.
plus 2x plus 3. Now watch when I hit the graph. Good job watching. All right, here we go.
I don't like that.
I want to go on the green roller coaster. So, I totally want to go on the green roller coaster. Do you guys see how right here, have the roots changed at all?
No.
No, just the graph has changed because we multiplied everything by 2, but the roots stay the same. So if you're making an equation, they say, I don't want any fractions or decimals, then you have to multiply everything by 2. But technically you don't have to. They're the same, they have the same roots, all right? Same roots, just different graph.
Do you always multiply by 2 or do you
Um,
look on the
What's in the denominator? It's always about what's in the denominator that lets you know what to multiply by. If there was 3's in the denominator, then you multiply by 3. All right? There we go. I want you guys to try one on your own now.